is the Math Man. I'm here to give you another math lesson on scientific notation. But before we get there, Math Man's legend is growing. We're already up to almost 50 subscribers. I'd love to see you get to 100, so I have something special for you if you get to 100 subscribers. But before we do that, let's go to the board. All right, students, now it's time to learn about scientific notation. So let's look at the definition first. A method for expressing a given quantity as a number, having significant digits necessary for a specified degree of accuracy, multiplied by 10 to the appropriate power. Now, I know what you're saying. Math Man, that doesn't make any sense at all. What does it even mean? Bruh. So I came up with an even easier definition for you. An easy way to display an extremely large number or an extremely small number. See, isn't that easier? So, for example, if we want to show the mass of the Earth's sun, which is a massively large number, we can use scientific notation because the mass of the sun is 1989000000000000000. You get the picture, right? Long drawn out number, no reason to do all that. So let's make it easy with scientific notation, shall we, students? The mass could also be expressed as 1.989 times 10 to the 27 kilograms. Much easier. If we want to display the mass of a grain of sand, a massively small number, we can also use scientific notation because the mass of a grain of sand, which we have a lot of here in Florida, is 0.0000000666 kilograms. So, to erase all those zeros, the mass could also be expressed as 6.66 times 10 to the negative 7 kilograms. Whew. Now, let's find out how it works. But before we do that, I have to do a little bit of review. If you recall from previous lessons, multiplying a number by 10 or a factor of 10, or dividing by 10 or a factor of 10, will move the decimal one place for each factor of 10 in the final product or the quotient. So let's do an example with an easy number we can all figure out on our own. 20 times 10. Now we should know that 20 times 10 would be 200. But let's look at the base number first, which is 20. Now, we'd have to identify where that decimal point is, and since these are both whole numbers, we're going to make them a decimal right there. So we have 20.0. Now that we know where the decimal is, we're going to move it one space to the right since we're multiplying. And it would go right to the end of that second zero, and now we've got 200. So it works out. Now, it can also work the opposite way. The same is true if you divide by a factor of 10. In this case, you're going to move the decimal to the left for each factor of 10. So, for an example, let's take this number of 500 and divide it by 10. And again, this should be fairly simple. 500 divided by 10 should be 50. So again, we'll look at our basic number that we started with, 500, and I put the decimal in there for you. Then we're going to move it one place to the left because we're dividing by one factor of 10. And that gives us 50. All right, so now let's look at a much bigger number, $532 million, and let's walk through it step by step. Now, if you've ever looked at the lottery and looked at what the value is for winning the lottery, sometimes it can be as high as $532 million. And you might have actually heard somebody say $0.53 million. Or you might have heard the term $6.2 billion. Basically, what they've done is use scientific notation and just left off the times 10 to the 27 or whatever, and they've just made it by the millions or by the billions or by the trillions. We're going to walk through this step at a time, by factor of 10 at a time, just to get you an idea of how this works. So, by removing a factor of 10, we're moving the decimal place one spot to the left. So now that went from 532 million to 53,200,000. But we don't want to reduce the amount of the number because we want to keep that number whole. So the only way we can do that and display it is by saying 532,000,000 times 10. Because that'll get us back to our original number of 532 million. So let's keep going. Next, we can take out another zero, and now we've got 5,320,000. But again, we have to keep that times 10. But this time, we'd have to put in 2 times 10s. Otherwise, we're not going to have the same number. Now, I know what you're saying here. It's going to look even longer now because now we've got all these times 10s on it, right? Well, we have those 2 times 10s, but we can combine them because when you multiply a number by itself, it becomes an exponent. So 10 times 10 would be 10 squared. We can continue doing this all the way along the number until we get to the very first number in the expression. So now let's continue. Let's take another 0, and now we have 532,000. And we'll just increase the number one more time, times 10 to the third, because that's easier than writing times 10 times 10 times 10. Let's continue. Take one more 0, 53,200. We have to increase the exponent by 1, so it's times 10 to the 4. Now we have 5,320 times 10 to the 5th. One more 0, 532 times 10 to the 6th. Now we're going to do something really cool. We're still going to move the decimal, but we're not going to remove the 2 because the 2's are valuable. The 0's are just placeholders. But we need these 3 numbers here. So we're still going to move the decimal, and we're still going to increase the factor of 10. So just watch how this goes. 53.2, we move the decimal one place from behind the 2 to in front of the 2, and now we're still going to increase the factor of 10, so times 10 to the 7th. Now we can move one more place, but that's it. We're going to move one more right here, 5.32, and we're going to, again, increase that factor of 10 times 10 to the 8th. So 532 million can also be expressed as 5.32 times 10 to the 8th. Let's write the number 12,300,000,000,000 using scientific notation. Now I chose this number because it's just so out there that you can't even imagine 12,300 billion of anything. So let's use this and let's find out how to do it in scientific notation. First, we write our number, and I went ahead and put the decimal place in there for you just so you know where it is. Now we're going to have to move to the left to get back to the beginning of the number to the important digits. So let's see how many times we have to go. Count in your head. All right, that's as far as we can go. So how many times was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So I want you to remember that number, students. That's very, very important. We're going to get to that at the last step. And you notice we've already moved the decimal place down between the 1 and the 2, which is where it belongs. Once we've done this step, now we have to continue with the next. We're going to remove all the zeros because the zeros are just placeholders and not important for scientific notation. Then we're going to add times 10 because all scientific notation displays the times 10 or the factors of 10 that we're multiplying by. And finally, we're going to add the exponent of 13. Hopefully you remembered that from before. The exponent is going to be positive because we moved from the end of the number to the left. 12,300,000,000,000 is 1.23 times 10 to the 13th power. Now let's try one with a smaller number. Write the number 0.0000000082 using scientific notation. So again, we write our number down. We don't have to put the decimal in because it's already there. But now, which direction do we have to move? We're going to the right. So let's try this again. How many times do we move, students? 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So again, remember that 9. That's going to be your exponent. Next, we're going to remove the zeros, which makes the quantity 8.2. Then we're going to add times 10 because all scientific notation shows times 10. And then finally, we're going to add the exponent of -9. And the exponent is negative since we moved to the right. All right, students, it's that time again. It's question time. We're going to be writing in scientific notation. I'll give you the large number or the small number, and you write it in scientific notation for me. Feel free to pause the video to work it out, and I'll give you the answers and some music to work by. So here you go. right, now let's try to make it a little bit more fun. Let's try to go backwards. Write it in standard form. I'll give you scientific notation and you write it in standard form. Here we go. Alright students, now you know what to do with scientific notation. So before I go, it's time to figure out what I'm going to do on my 100th subscriber video. So if you have an idea what I should do, leave it in the comments below, and don't forget to subscribe, like, and hit that bell so you can see every video that comes up when MathMan posts it. Have a great day, students. See ya.